This submersible is diving in some of the richest, most exotic, most unexplored waters in the world. Scientists aboard the sub, using its unique ability to chase and capture live fish and other creatures in deep water, are bringing back extraordinary sea life, including specimens of fish never seen by human eyes.
I saw more new critters on this dive than I've ever seen on any other dive in my life.
On expedition in the waters of the Galapagos Islands, they are discovering, on average, a new species every day.
The video we've taken on this is great. Fish everywhere.
For a marine scientist, this is the ultimate.
Bizarre midwater squid.
Those are actually sea cucumbers, and we've seen shallow water sea cucumbers, and now you're seeing what a sea cucumber looks like in the deep sea. These are really strange. This is a scientist's dream come true. To spend a month at the Galapagos, every day in the water, in the sub, working with these animals. It's a high that'll take a long time to come down from, but there's going to be a lot of work when we get home. It'll probably be 6 months or a year before we really even understand all of the information that we've gathered from this expedition. But no doubt about it, Galapagos is Mecca for a biologist, and here we are in the Holy Land.
On station in the world's foremost natural laboratory of evolution. A discovery expedition to the Galapagos, beyond Darwin.
We have a seal.
The Galapagos are dots of land on a vast Pacific. From the 1600s on, they were a lonely stopping place for pirate vessels and ships drifting off course. Now, instead of a place you get to by accident or bad luck, the Galapagos are a magnet for travelers, and especially scientists attracted by the chance for dramatic discoveries.
It's silly to think that the age of discovery is over. It'll never be over. It will keep going and going and going. We'll learn all kinds of new things. I can't wait to be old and gray and have some new person come out and start digging up fossils out here and tell me how wrong I was. Be no problem, be fun.
In 1835, these humble, unknown islands were visited by a humble, unknown scientist, Charles Darwin. He was the first scientist to set foot here. Now other scientists come in his footsteps, drawing on this almost magical source of knowledge about the evolution of life.
Actually, so excited, I can't describe it. I gotta go warm up and be able to explain it to you.
160 years after Darwin's visit, the Discovery Expedition arrived to gather new knowledge from these islands, from Galapagos worlds Darwin never saw, underground and underwater. The Harbor Branch research vessel Seward Johnson reached Galapagos after a 10-day, 2,000-mile voyage from its home port in Florida. Aboard were 38 people, the ship's crew, the Discovery film crew, and a scientific contingent. Spending 1 month in the spectacular waters of the Galapagos, scientists made 55 deep dives by submersible and many more shallow water dives by scuba. The submarine dives yielded fantastic deep-water specimens, many of them staying alive for hours or days, long enough for close-up study and living documentation.
Well, every biologist cuts his teeth on Charles Darwin and the Voyage of the Beagle and the Galapagos. It's such an extraordinary place because the process of evolution occurs right before your very eyes. You can see how these different islands allow for the finches or the tortoises to radiate and speciate and evolve. But few people appreciate that the same thing happens underwater.
Charles Darwin, when he arrived here, didn't know about evolution underwater, or for that matter, on land. In fact, when the Galapagos offered him a hint of nature's greatest secret, he didn't see it. The Charles Darwin who landed on this beach was 26 years old, a medical school dropout, a young man whose sole passion was observing nature. Following this passion, he signed on as ship's naturalist for a 5-year voyage aboard the British survey ship Beagle. After mapping the South American coast, the Beagle started home across the Pacific, making a fateful visit in the Galapagos, 600 miles west of South America.
I have a hard time comparing what I do with Darwin too much because, to be honest, I think it's pretty egotistical, even though it sounds good. And when you go to Galapagos, automatically there are comparisons with Darwin. That's almost unavoidable. But Darwin was cutting edge. His observational ability was unparalleled.
But it didn't take unparalleled ability to observe the wonders of the Galapagos. Darwin beheld a fantastic spectacle. He saw giant tortoises, thousands of them. Birds with shriveled wings that had given up flying, but thrived as shoreline divers. Penguins and fur seals and sea lions, creatures associated with cold climates, but the Galapagos are on the equator. He saw land iguanas, resembling those he had seen in South America, but he also saw sea iguanas that fed underwater, a creature never seen anywhere else. Darwin spent only 3 weeks ashore in the Galapagos, visiting 4 of the 16 islands. He took notes and filled his bag with specimens, then he left. He may have had inklings of evolution, but he didn't see the light. Understanding what he had seen and working out a theory explaining it took a quarter of a century. It's one of the great sagas in the history of science. Darwin's theory of evolution shook not only the scientific, but also the religious and social foundations of the Western world. The reverberations of Darwin's theory are still felt today, felt with a passion. It's the passion of fundamentalist religion, raging against Darwin, insisting on a biblical version of creation.
That one's deeply forked.
It's also the passion of scientists who believe that Darwin opened new worlds of knowledge, who build on his insights in an ongoing process of science, who regard such fundamental evolutionary principles as natural selection as an unshakable premise of their work.
But its closest relative is in Hawaii. You know, the irony of all of this is that here we are on a very, very modern ship, and in fact, with the Discovery program, we've had email, and one of the first emails we got was someone asking the question, does your experience in Galapagos change your view about that controversial theory of natural selection? My response was, Madam, it is not controversial, and it's not a theory. It's a fact. I only wish that we could take everybody on this planet and send them to the Galapagos to see natural selection in action. It's so obvious here. Aboard the Seward Johnson were 3 top authorities on sea life. was just crawling across the bottom at about 1650.
The expedition's chief scientist, Dr. John McCusker of the California Academy of Sciences, an expert on shallow water fishes.
Doing okay. It's a little warm up here on top, though. We got to get in an ice bath.
I believe it's a medusa, or jellyfish. But
Dr. Bruce Robeson, a deep-sea specialist from the Monterey Bay Aquarium Research Institute.
This is one I've never seen before, and it's remarkable.
I think this is the male of the new species of lopers that we have.
And Dr. Grant Gilmore of the Harbor Branch Oceanographic Institution in Florida, an authority on Atlantic and Caribbean marine life, studying comparative evolution in the Galapagos.
Beautiful fish, very difficult to capture.
Well, as a strategy, I assembled a crew of scientists that could both examine the deep ocean, as well as the rocky reef, as well as the shallows. And then we threw in Stedman to give us a reality check. He's a birdman who's never been underwater.
The birdman was Dr. David Stedman of the University of Florida. Stedman is an expert on Galapagos wildlife in the present, but also in the past. As a paleontologist, he's done extensive work on the evolution of land life in Galapagos.
A big difference between what I'm doing and what the marine biologists are doing here is that, I'm going into the past to look at evolution. So I'm digging down, and by only digging down a meter, I might get back 10 or 15,000 years, but nevertheless, I'm going back in time to see what has happened evolutionarily. These guys are studying organisms that are still alive today. So the studies that they do are based purely on living fauna, and there isn't a fossil record out here that would allow them to go back in time.
Darwin, not having a face mask, was unable to get underwater and really appreciate that evolution's going on there too. So I often thought, what would Darwin have thought if he had been able to do what we're going to do on this expedition? Would he have realized that nearly everything underwater here has different factors affecting their survival, their evolution, which makes it more challenging and more interesting to an evolutionary biologist.
Also on board was a leading underwater filmmaker, Al Giddings. Giddings has shot underwater scenes in many documentaries and in feature movies including The Deep, The Abyss, and several James Bond films.
I've seen my fair share of the undersea world, but Galapagos, with the tools that we have here and the scientists that are on the front line here, is incredibly exciting because everything that we're doing is sort of a first. Nobody's really gone below probably 200 feet here, so anything below 200 feet is relatively new to science or totally new to science. So I'm always excited to be on the cutting edge of that kind of new frontier.
I believe this is the first time that any kind of research submersible has ever been available to study the deep living creatures that live here around the islands. Being able to be an explorer in the sense of a 19th century explorer, only one who uses 20th and 21st century technology to make those explorations is very exciting.
The urge to explore is timeless, but the technology changes dramatically. Charles Darwin's undersea technology was just a fishing line and a small tow net. His land tools weren't much better. On the Beagle, he was lucky to get a corner of a table as workspace. Except for mail at long intervals, he was totally isolated from the scientific community. Everything Darwin didn't have, today's scientists do have. For instance, this sub, the Johnson Sea Link.
Okay, Phil, we're ready.
Don Libator is one of its two pilots.
We're ready to boom out.
This is Johnson Sea Link number 1. What you're looking at is the front end of the vehicle, and this is the acrylic pilot sphere. It's about 5¼ inches thick of acrylic, and the pilot and the scientific observer sit up in there, and all the controls for the submersible are up in that area. This is the hydraulically operated manipulator arm system. It's a 7-function arm, and we can grab things off the bottom with this jaw over here. Or we can collect fish by sucking them up through this tube. Once we pick them up, we can install them in this basket here. The lid opens up, and up on top of the basket is a 35mm camera that is laser aimed, so we can get the photographs in very sharp focus. Over here, we've also got a video camera with lights on it and lasers to document the things that we see on the bottom. And in the front of the vehicle here, this is called the lower work platform. It's a collection device where we have 12 plexiglass buckets that we can rotate around on a chain, so when we pick up a sample and put it in there, we can always have a fresh one available for a new sample. Down over here, this is how we drive the vehicle. Each one of these switches represents one of the thruster motors on the outside of the vehicle, and by throwing different switches, forward or reverse, we can get the sub to go forward, we can get it to go in one direction, we can get it to go sideways if we want it, or we can go up and down. Down in the center, we have our video control console, which is right up here. And this controls the pan and tilts and all the zoom and focus and different camera selects and lights. And of course a video monitor so we can watch what's going on through the external camera. Should I be unable to bring the submarine to the surface, the first thing you need to do is to take my headset off, the pilot's headset, put this little earpiece in your ear, and press the button right here on the top of the box. It's labeled UQC. That's our underwater telephone. Should we be stuck on the bottom for a while? A while. The life support in this vehicle is good for 5 days. We've got enough chemical on board, we've got enough water-making capabilities, warm clothes, and food to keep us alive for 5 days on the bottom.
Midway between the high-tech of today and the no-tech of Darwin were 2 expeditions in the 1920s led by Dr. William Beebe of the New York Zoological Society. Beebe's equipment included a waterproof motion picture camera shooting silent movies of his underwater adventures in the Galapagos and Caribbean. Tethered to an air hose, Dr. Beebe couldn't go more than 20 to 30 feet down. But he reveled in the emotion that drives explorers, the thrill of being the first to enter a fabulous new world. Later, he wrote a book describing his experience.
The sun's rays filtered down as though through the most marvelous cathedral ever imagined. One had to sit quietly and absorb this beauty before one could remember to be an ichthyologist. I shut my eyes and recited my lesson. I am far out in the Pacific on a desert island, sitting on the bottom of the ocean, in a place where no human being has ever been before.
Back on the mothership, a yacht borrowed from a wealthy patron, the scientists did their work, drawing and cataloging fish specimens. These specimens were collected sometimes in swashbuckling style. Here, a manta ray was repeatedly shot with a rifle, harpooned, and then blasted to death with a pistol. This would be unfashionable by today's standards, but it provided a trophy to be proud of. Dr. Beebe's Galapagos expeditions led to the discovery of 2 species, and his film and book awakened the public's imagination, capturing his enthusiasm and fascination for underwater exploration.
All I ask of each reader is this: don't die without having borrowed, stolen, purchased, or made a helmet of sorts to see for yourself this new world, this unsuspected realm of gorgeous life and color.
On the Discovery expedition, the Johnson Sea Link submersible entered this realm of life and color 2 or 3 times a day, diving by day or night. Each dive lasted 3 hours and carried 4 people, a scientist and pilot in the forward bubble, another scientist and backup pilot in the aft chamber with a porthole view. The sub moves under its own power and with no connection to the research vessel which hovers overhead, in contact by sonar and acoustic signal.
Don, can you give us a bottom report, please? Give us a bottom report, over.
Right now, what we've got in front of us is kind of looks like a sediment and rubble covered slope with not much here, not much on it, so it looks fairly new.
Yeah, Don, you're an hour into the dive. We just want to make sure you pace yourself to be sure we get time for the rocks that you need to collect at the top.
Deepwater diving is inherently dangerous, so every precaution is taken. A remotely operated vehicle guided from the ship is available to help rescue the sub if it became entangled underwater. In case of a long wait for rescue, the sub carries a 5-day supply of food and drink and thermal clothing to prevent freezing. A serious danger in deep water is the crushing effect of water pressure. To illustrate it, Bruce Robeson and crew member Ben Chong tied a decorated styrofoam mannequin head to the sub.
Were that force applied to our bodies, most likely the squish would be very uncomfortable. You wouldn't want to come back.
They measured the head, 11 inches, and then watched its slightly panicky face as the sub dragged it below. The Johnson Sea Link has a maximum depth of 3,000 feet. At that depth, water pressure is 1,350 pounds per square inch. What that pressure would do to an unsheltered human or mannequin head was evident when the sub came up.
4 inches, Bruce.
From 11 to 4.
Yeah.
That's quite a shrinking job. What a difference.
That's it.
Hey, that pressure's powerful stuff. I'm glad it was her and not me. As we approach this, you don't know what it's going to be. It first appears just as a dim shape out in the darkness. As you get closer and get a better look at it, you get a feeling inside that starts to grow. You think, I don't recognize it. I don't know what it is. And then you come in close and begin to get a little more analytical and a little less emotional. But there's no getting away from the thrill that comes with realizing that what you've come upon is something new and perhaps something that's never been seen before by anyone. This is the sort of thing that you hope for on an expedition like this. You know you can't count on it, but this is what you're hoping you're going to find. Something new, something undescribed, something that'll help you put together the little bit of the unknown that you have a chance to reassemble in your mind. Most sea cucumbers live on the sea floor, but this one has evolved to make a living up in the water column, well away from the bottom of the ocean. During their life cycle, they never touch the sea floor or contact any surface. It feeds on marine snow, particles that sink down from the surface. It's very fragile, very difficult to observe in any situation other than being there directly. In the past, the only way to study animals that lived in the water column was to drag nets through the water. Nets rendered them into just so much unrecognizable goo. We could not count or identify what it was we brought up of these gelatinous creatures. But by using the submersible, by entering the habitat directly and becoming part of it, we can reduce the lights, we can reduce the noise from the submersible, we can make it very quiet. The kinds of things that we're able to learn then are more than just who lives there and how many of them are there. We get to see the dynamic interactions between species and within species that help us to put together a picture of the ecological function of this very unique community here around the Galapagos.
You're looking at the first footage of a living telescope fish just after capture with the submarine.
An example of the benefits of seeing creatures alive in their habitat rather than dead in a net. Caught in a net, this fish would be assumed to be a horizontal swimmer, like most fish, but it's not.
This fish was oriented near the bottom with his head pointed up, telescopic eyes looking towards the surface. Long tail is easily 3 times the length of the body, extending down below him. Now, he's apparently going to ambush prey, and many of the fishes we're capturing have this posture, tail down, head up.
So perfect. There's not a scratch on it. Historically, fish that have been captured at great depths with nets come up dead. They're all dead. We don't know anything about their swimming behavior. We don't know a darn thing about them other than we have a dead fish in our hand. But with this submersible and our ability to gently capture by inhalation these delicate specimens at the surface can tell us a lot about their biology, their swimming behavior, how they relate to one another, what they feed upon. And you gotta admit, just for the first time seeing these animals alive allows us an opportunity that people haven't had before. You think it's gonad or something?
Hard to say, but that patch back there,
Do they have any bioluminescent?
That's what I'm going to look for next.
Maybe that's just a container that squirts out like a squid or an octopus squirts out ink. People ask me, do the fishes evolve? Well, of course they evolve. In fact, they've evolved into more than 25,000 living life forms in the sea. And the manner in which fishes evolve is the same as the manner in which the birds, plants, and all the other living things in Galapagos evolve. It requires that somehow they get there in the first place, and the larval forms get here and are isolated here. They mutate, and then the successful adaptations are rewarded, and the result is endemic species at Galapagos.
Many of the fish of the Galapagos were once the same fish that swam in the Caribbean. The Pacific and Caribbean were connected by an open waterway, sort of a natural Panama Canal. But then, 3 million years ago, came a critical evolutionary event. Shifting continental plates pushed up the land, now called Panama, forming the Central American land bridge, closing the passage between the Caribbean and Pacific. Marine creatures were separated forever, divided into Pacific and Caribbean species. They began diverging. In different environments, they evolved in different directions.
There are so many opportunities to adapt to life in the ocean as compared to life on land. There is every possible environment here underwater. So fishes have just taken full advantage over their 400 million years of opportunity to evolve and take full advantage of every possible adaptation. There are still new species of fishes evolving, and there are still new species of fish to be found. And it's hard for us to understand as light viewing human beings at the surface of this planet why these fish are so darn colorful. And with the sub, with the lights on, we're just amazed, kind of whacking ourselves in the head, saying, why the heck is that fish bright red, yellow, orange, what have you? And we turn the sub lights off. We'll allow our eyes to adapt to that very, very low light level, even 1,200 feet below the surface. And you realize that there is some light penetrating through this clear tropical water. And the fishes that are just jet black would stand out like sore thumbs. But these very colorful fishes all of a sudden fade right into the habitat. They look like the sea fans. They look like the broken rock reef. That color is very adaptive. Now, why they're so beautiful is beyond me. I can't imagine there's an advantage to that.
I don't want to get stung. This is a pretty pointless fish.
Look at that. Up in the light. It's about half head and half fish. Dr. Seuss couldn't invent the fish like this.
His eyes before the water that they're in, which is off the cold.
Look at that guy. Look at that fat fish.
Yeah.
Look at that thing. It's just galumping across the bottom. We had to chase it. Everybody looks at it and they think this is a primitive, ancient fish. This is so modern. This is so specialized. This has come a long way from being a goldfish. Look at that crazy thing. It's got a fishing lure. Look at his eyes. Beautiful, beautiful batfish.
The Galapagos evokes scenes of tranquility and a sense of timelessness. They seem to have existed forever, never changing, serene and undisturbed. This is how it feels, but not how it is. This eruption in the Galapagos took place in 1995, caused by the same volcanic forces that formed the islands about 3 million years ago. This place on the globe was nothing but vast, empty ocean. But then lava came boiling up from deep in the earth, underwater cones of lava rising, ultimately piercing the surface and cooling to form islands. Similar eruptions formed the islands of Hawaii. But people got to Hawaii many centuries before they arrived in Galapagos. What makes the Galapagos such a perfect natural laboratory is that, unlike Hawaii, evolutionary clues have not been trampled over by human activity. But at first, there was nothing to trample over. As the lava cooled, there was no life, no soil, no growth at all.
Any visitor to Galapagos is really struck by this barren lava that you see along the coastlines. There's nothing growing here. There's essentially no soil development. But eventually, with time, soil will begin to form just barely, very slowly. A little bit of organic matter, maybe an odd seed or two will drop here and there. So lava is the beginning. So it all starts with geology.
After the eruptions that created them, the islands waited in dark solitude. Hundreds of centuries went by. Winds and tides carved out strange topographies. While some life arrived from the start, colonization took place with unimaginable slowness. A few birds blown out to sea from South America, insects and small animals floating on clumps of land broken loose from the mainland, seeds of cactus and grasses carried on the wind or by birds. These drifters on the sea or air were the pioneers of the Galapagos. Marooned on these desert islands, they managed to sink roots and start colonies. And here, the Darwinian story begins. They started adapting, becoming different from their ancestors on the continent. different even from creatures of the same kind on neighboring islands. For many Galapagos species, adapting meant evolving darker colors than they brought from South America. The darker color allows the animals to use the lava background as camouflage against predators or as a way to fade from sight as they wait to ambush prey. The Galapagos lava lizards are hard to see against the dark background, as are most of the snakes in the Galapagos. A predator feeding on lizards and snakes is the Galapagos hawk, which itself blends into the dark island backgrounds. But then there are times when coloration is used not to avoid attention, but to seek it. In the mating season, the male land iguana, which is normally drab, changes into flashier colors to catch the eye of an iguana female.
This is a great time of year to look at land iguanas up close. The males are more colorful this time of year. They've got sort of bright yellows and oranges. But this time of year, they look really nice, even sort of purples and blues sometimes. So they're getting all pumped up for the mating season.
Comparable to iguanas as a Galapagos emblem are the giant tortoises for which the islands are named. Galapagos is Spanish for tortoises. The tortoises have evolved different shells, domed or saddleback, depending on available food, or more accurately, whether the food requires them to raise their necks to nibble on cactus or merely to browse at ground level. They've also adapted to a different role. Tortoises are reptiles, but in the Galapagos, they fill a niche normally occupied by mammals, simply because large mammals couldn't make the trip by wind or sea to the Galapagos.
As far as their role in the ecology on these islands, giant tortoises in Galapagos are sort of the main herbivore, the big-time browser and grazer. There are no large mammals in these islands, so in a way, these tortoises are sort of the equivalent of what bison would be on the plains in North America, or what wildebeest would be in East Africa.
Except that bison and wildebeest can move fast when necessary. Tortoises, with no predators chasing them and no competition for food, had no need for speed and evolved as slow movers, often living past the age of 100 without ever being in a rush.
When you see tortoises up in the highlands wade into a pool, they don't just sort of wade in, splash down, and then leave. They wade in the pool. They keep their head above water, but other than that, they might sit there for a day or two at a time and essentially not move. This is the large herbivore on the island, and there's really no need for them to move fast. Except for people being around, they're calling the shots. Before there were any people here, tortoises really didn't have much of a problem.
But when people arrived, the tortoises had a big problem. This is Tagus Cove, an anchorage favored by pirates and whalers from the late 1600s to the mid-1800s. They came here not just to carve graffiti into the walls, but to load their ships with tortoises, plentiful, nutritious, delicious tortoises.
Tortoises were a great source of food for early sailors because tortoises can live for months, oftentimes 6 or 8 months, without eating or drinking. I mean, it's horrible for the tortoises, but for people out at sea, these tortoises were a real godsend. You could take tortoises from the inland down to your ship, turn them upside down so the tortoises were helpless, couldn't move, and literally fill your hold with tortoises. Whaling records record thousands and thousands of tortoises taken from Galapagos during the whaling heyday in the early 1800s. You see figures of 100,000, 300,000, 500,000, 1 million tortoises removed from Galapagos. And it was at that point the tortoise populations really crashed hard.
Ironically, even Darwin and his shipmates on the Beagle consumed a load of tortoises on the voyage home. The remains were thrown overboard as garbage. no one, including Darwin, realized what valuable evolutionary evidence they would be, showing tortoises on different islands evolving into different species. One species Darwin had seen and probably eaten, the Floriana island tortoise, went extinct only a few years after Darwin's visit. Scientists in later expeditions searched for its bones, but they weren't found until the 1980s. By David Steadman. An interesting theory about the origin of the Galapagos came out a few years ago. Geologists found underwater mountains called seamounts between the Galapagos and South America. There was evidence that these volcanic seamounts are sunken islands that may once have been part of the Galapagos. Their summits are terraced and strewn with rounded basalt that looks like Galapagos beach pebbles.
We're going to dive on a sunken seamount that probably is older than anything else in the Galapagos.
Similar seamounts exist in Galapagos waters. Scientists on the Discovery expedition devoted part of a submarine dive to take a look at one of them.
We got a chance, Grant and Don, to demonstrate that these were once at sea level, if in fact you can find some rounded basalt, some golf ball shaped rocks on top of this that could only have been eroded by beach action.
Sunken islands suggest that certain species evolved on Galapagos Islands that have disappeared. The creatures simply moved on to younger islands.
Did you get any rocks?
Sure did. It came up, it was almost at a 90-degree angle at the edge. I mean, it just came right up and then went right across the platform. Looked like an island. You just raise it up another 900 feet and it'd be an island.
It all starts with geology. Volcanoes formed an oceanic basalt off the coast of South America here on the Nazca Plate, which is moving towards South America. So the islands are getting closer to South America as we speak, maybe a few centimeters a year. But eventually, the Galapagos Islands are doomed to sink beneath the South American plate, go beneath the Andes. So get here while you can. It'll probably be a few, maybe tens of millions of years before that happens.
Scuba divers in Galapagos can find heat bubbling up from vents in the ocean floor. This heat is escaping from a volcanic hotspot beneath the ocean, the source of magma that rose up to form islands. This rubble is cooled lava from the 1995 volcanic eruptions. It's barren now, but vegetation and sea life will come. This is the newest addition to the Galapagos as the archipelago itself continues to evolve. When Dr. David Steadman goes to the Galapagos, he heads for the caves, actually huge tubes hollowed out by fast-flowing lava during volcanic eruptions. In 1977, Steadman proposed digging in these lava tubes for fossils. The scientific community found it the idea of a young man who had not quite come to his senses.
A few people thought it was a good idea and said, go for it. Most people thought it was a silly idea. Some people told me that it was beyond silly and I should just get an elementary geology book and look it up and realize that the Galapagos are volcanic and that fossils are found in sedimentary rocks.
But Steadman's idea paid off, thanks to the eating habits of the Galapagos barn owl.
There's a little species of barn owl that lives in Galapagos, and like barn owls everywhere, it eats different kinds of vertebrates, lizards, snakes, birds, bats, rats, things like that, and then digests the soft parts, coughs up a bony pellet. And the ledges that you see in this cave are perfect places for barn owls to roost. And so these really rich fossil sites that we excavate in lava tubes in Galapagos represent literally thousands of years of owl vomit. And by doing that, the owls are giving us this continuous record of what's going on with species in the islands.
This lava tube on Santa Cruz Island is about a mile long and big enough to drive a bus through. Collapsed sections of its roof made a convenient entrance for owls. Lava tubes are sheltered from the weather and chemically favorable for long-term preservation of fossils.
This is a leg bone of a mockingbird. Mockingbirds are still pretty common on Santa Cruz Island here. This humerus is from a Galapagos dove. Galapagos doves aren't very common on Santa Cruz anymore. They've been wiped out on some islands by rats and feral cats, but they're still real common on uninhabited islands. This is one of the leg bones here of the extinct giant rat of Galapagos. It's a rodent that was about as big as a muskrat and lived until only about 100 years ago. This particular lava tube has yielded about 30 species of reptiles, birds, and mammals. And of those 30 species, 10 of them no longer occur on the island of Santa Cruz, and about 5 of them are extinct everywhere, forever. What I've discovered in Galapagos is that there's essentially no extinction going on before the arrival of people. In other words, the floras and faunas out here are getting richer and richer with time until the arrival of people. Boom. That's the big event that throws a monkey wrench into the whole process.
David Stedman has spent a total of about 1 full year digging in the Galapagos. His findings prove that the richness of the islands as a fossil site is no longer in doubt.
We've excavated approximately 600,000 or 700,000 individual bones. These sites go back as old as 23,000 years, so we're developing a very beautiful record of long-term changes in the flora and fauna out here in the island group. This is really important for evolutionary studies because, of course, evolution doesn't just happen overnight. To deal with many of the big pictures of evolution, you need long periods of time.
What Stedman calls the mother lode in the Galapagos is Barn Owl Cave on Floriana Island. He's been there several times, but still finds the entrance a little tricky. Once he's back on level ground, however, Stedman strikes evolutionary gold. After several days of careful digging through layers of sediment revealing animal and climate changes reaching back to the Ice Age, he hits his jackpot, the shell of an ancient tortoise.
This particular tortoise specimen is really important because it's the oldest tortoise fossil that I have from the Galapagos. Assuming that this tortoise is 12 or 14,000 years old, we can extract DNA from that bone, compare it with DNA from modern tortoises, and see what kinds of genetic changes have occurred in the last 12 or 14,000 years. And because Galapagos is such a mecca for studies of evolution, it's a crucial piece of the puzzle that's missing.
The tortoise wasn't the only creature to leave bones in this spot. There were also bones of lizards and snakes, birds and bats, a total of as many as 40,000 individual bones in this single dig. Studying DNA from these bones, Stedman and other scientists will be able to create a record of thousands of years of genetic change on Floriana Island.
This cave has now become, after this excavation, maybe the most important fossil site we have so far in the Galapagos. This is my 10th trip down here. I was starting, and 5th trip to Floriana, to this individual island. So I was starting to think, well, maybe there's not much more to learn here. But as always, when I start thinking that, I'm wrong.
If an alien civilization were to come to this planet, and their instructions were to explore and to study the most important animal communities. They wouldn't be up here on the surface looking at us. They'd be down in the deep sea, because those are clearly the largest and most dominant groups of animals on the planet Earth. Because they're out of our range of experience, because it's not easy for us to explore them or understand them, we don't think of them. The animals that live there, we have explored and described less than 2%.
The Discovery expedition was exceptionally successful in bringing deep-water animals up alive, despite the shock of changes in water pressure, light, temperature, and environment. Specimens survive for hours or even days, long enough for thorough documentation.
When you place fish in preservatives and fixatives, they typically lose their color rapidly. Most often the yellows and reds are lost within 24 hours. And many of these fishes we're bringing up from the deep sea have reds and yellows. They're brilliantly colored.
Brilliant color should catch the eye of predators, but in deep water, the opposite is true. Sunlight is filtered, and colors at the red, orange, yellow end of the spectrum fade out, making bright fish hard to see in weak light. So color is an important protective adaptation in deep-water fish, and having fully colored living specimens to draw and photograph creates a major improvement for scientific documentation. Video, in fact, is now a full-fledged tool of science. The submersible's video cameras provided part of the expedition record, but the aquarium and underwater scenes in this documentary were shot by the highly experienced underwater filmmaker Al Giddings. His presence to shoot the Discovery documentary was a bonus for the expedition's scientific record. The normal scientific expedition could never afford his state-of-the-art video equipment or his sophistication in underwater cinematography.
At times, especially when I'm shooting interiors with a handheld camera and exteriors with a pan and tilt exterior underwater camera, sort of like a video game. I mean, you're trying to use the lenses creatively, and a lot of the time, rather than pan or tilt, I'll try to draw the pilot's attention from what he's seeing out through the front of the submersible to the monitor and actually have him fly the monitor. And I'll say, Don, keep the animal, you know, in the center of frame. And so he's there with a joystick. I'm pulling focus, changing aperture, doing whatever I'm doing, and he's trying to keep that subject centered up in the monitor. The JSL submersibles are only 59 inches. So you're working in a 5-foot sphere, 2 people, with a ton of electronic gear. So it takes us sometimes an hour to prepare, install, plug everything in, and then at the end of a dive, you take it all out. 2 dives later, you're in again, and so the sort of mechanical, electronic elements of doing images from a submersible are especially challenging because of the complex nature of installation and making sure that everything functions properly.
Giddings made 16 deep dives in the sub, but also covered shallow water explorations with John McCusker and others.
In order for us to understand what lives here underwater, we have to use scuba as well as the sub. The sub is wonderful for deep water, but from 200 feet to the surface, the sub is not maneuverable enough, and there's just too much surge and motion. So scuba is perfect. Lions are probably the largest animals visitors to the Galapagos experience.
And they certainly are an experience. They're very, very curious, and they just downright play with us. And it's a lot of fun to have a sea lion swim around you, except sometimes the big males, the big bulls that run these harems will swim right up to you when you least expect it and blow a blast of air in your face. They're trying to tell you, get out of my territory. They spend more time cavorting with each other and just plain old fooling around. Maybe it's training, maybe it's learning, but it just looks like fun to me. And here in these grottos, we really have an opportunity to see them at their best.
You know, I'm just dazzled by what I'm seeing here. The reef we were on 2 days ago, my guess was we had 500,000 fish in a dozen schools. Probably 1,000 sharks, hammerheads, patrolling the outer perimeter of the island. Biggest hammerheads I've seen anywhere. I mean, close up, probably had 10, 15, 20 in the frame at the same time. Beautiful big silhouettes. School of Barracuda, you could hear the Mormon Tabernacle Choir looking up through them. Probably 2,000 in the school. Great, big, beautiful ball with a hole in the center of where I was exhaling. You know, just great swarm moving around.
Al was taping John McCusker underwater when they started having individual encounters with sharks. A highlight was McCusker's meeting with a whale shark, a species that can reach 50 feet in length. This one was about 20 feet.
I've never been so close to a whale shark before, and this is the world's largest fish, the world's largest shark. It is rarely seen. Looking into its mouth, I felt like it could chase me down and swallow me, but it didn't. It swam up, looked at me, and allowed me to examine its lips, its mouth, its skin. Although it was shark skin, it wasn't rough and spiky shark skin like so many other sharks. You see, shark skin is embedded with thousands and thousands of teeth. But this shark has relatively smooth skin. It's a most extraordinary feeling.
The schoolbook myth about Charles Darwin is that he came to the Galapagos, glanced at its unique wildlife, and instantly solved the mystery of evolution. Well, not true. The real story is better. It's better because instead of treating Darwin's insight as a miracle, it's about an enormous struggle for knowledge.
One of the problems with attributing a species name to this is that the specimens that they have are pretty small.
Rocks, there is no way that a fisherman is going to catch this fish and get it out of the rocks and bring it to the surface.
Although these are in fact the juveniles, and I think these are, based on the color pattern and the counts, the meristics are the same.
If that's a juvenile, Grant, the adult's as big as a basketball.
That's right. So you have to start somewhere.
It shows Darwin working in a tradition and scientific process that closely parallels the work of the Discovery expedition.
The preservation of the specimens that we capture is very critical to their future value to other scientists. Now, I, for example, was able to examine and hold in my very hands the specimens that Charles Darwin collected at the Galapagos 160 years ago, and they're still very valuable.
It's about the sharing of knowledge among scientists, their faith in knowledge, and their contribution to future knowledge.
What I'm going to do is spread the fins, release the gas, put a slit in the body so that the formaldehyde can enter its tissues, straighten the specimen out, write very careful descriptive labels about its point of capture, its depth of capture, and all of the color notes and other information that I have in my logbook. And then all of this will end up on a computer file somewhere so that anyone can have access to that very valuable information. And some of the specimens will have tissue removed and stored in ethyl alcohol so that DNA analysis can be done of those tissues.
Darwin wasn't so careful, mislabeling some of his specimens, not bothering to note which islands they came from, not realizing that species had diverged from island to island. The evidence of evolution had not yet registered in his mind, but it was there in his specimens. New forms of life had emerged, new species.
At this stage of the game, I guess it's probably a new species. It may even be a new genus or something larger than that, because it is so different from anything we've ever seen before.
Bruce Robeson is talking about the process of identifying a specimen. In this case, a specimen so fragile it could be captured only on video.
The way that we'll go about establishing whether or not it is a new form is to make a lot of copies of the video footage that we have and send them to experts and colleagues around the world to see if they are familiar with the form, whether they recognize it or anything like it.
Feedback from the scientific community has always been important in science. In 5 years at sea, Darwin got no feedback at all. But the Discovery scientists got it on satellite email, like John McCosker's getting a quick opinion from an expert at Scripps Institution of Oceanography.
I'm describing this new species of fish to Dick Rosenblatt. He probably knows as much about this group of fishes as anyone, and I'm asking him, what the heck have we got here? Has he ever heard of such a thing, and what is going on with the coloration of this fish? The fact that it's all pink, red, yellow, something that we're not accustomed to at all in terms of fishes from Galapagos or probably anywhere else in the Eastern Pacific. This is a very strange fish. We know what its relatives are, but we just don't know what it is.
When Darwin returned to England, his specimens were quickly sent out for evaluation by leading scientists. In March of 1837, he went to London to hear their findings.
Finding a new fish, or seeing a new fish, or observing new behavior, that's the exciting part. Then the hard work begins. You've got to go back and go through all the literature and talk to your colleagues and make sure that what you're seeing is really real. Go over the films, go over the specimens, and months and months and months from now, I'll be able to say, aha, we really did see something unique and something new.
The body, the overall morphology of the fish is quite different from any Lioprompoma I've ever seen.
Something unique and new. That's exactly what the experts told Darwin about his specimens. In a conversation that left Darwin frantically scribbling notes, the great ornithologist John Gould pointed out that of 26 land birds brought back from Galapagos, 25 were new species. 3 forms of mockingbirds Darwin thought were just slightly different were in fact distinct species descended from a South American ancestor. Finches had radiated in the Galapagos from 1 original species to 13. Darwin was stunned. the evidence that species could change challenged the biblical version of creation in which he and most Westerners believed. Religion said life was created in a day, in a touch by the hand of God, that humans were supreme, formed in God's image, and certainly not descended from the animal world. The Bible said that all creatures were designed by God, a design that would never change. But Darwin's specimens said otherwise. On islands just 40 or 50 miles apart, species branched off in different directions, different identities. They adapted, they evolved. And if they evolved, perhaps humans had evolved, and perhaps the Bible, which dominated Western thought, was wrong. Darwin became an evolutionist, courageously pursuing a vision much larger than that of the experts who had helped him indispensably. His theory of evolution was described in On the Origin of Species, his masterwork, published in 1859. When Darwin died in 1882, he was buried in the place of highest honor, Westminster Abbey. He lived 73 years, but said that all his views reached back to the islands where he had spent a few innocent weeks practicing science at the age of 26.
It's no coincidence that I'm out here now, not in the office. You know, I mean, I got into this game because this is just the sort of thing I like to do. We all need to push a little paper, but that gets old after a while. So this sense of adventure, going to new places, working hard, getting dirty, comparing notes, what did you find today, how's it going, is really, I think, why most field biologists got into the game.
David Stedman returned to the research vessel with over 50 buckets of dirt from Barn Owl Cave.
What'd you discover?
Oh, we've got all kinds of good stuff.
Man, you guys collect. When you collect specimens,
Here's a nice light one.
you need a dump truck.
We hit the mother lode. The cave that we knew we were going to excavate ended up being better than we'd ever thought. And we got down about 1 meter deep. I would guess maybe 12 or 14,000 years old. So second oldest site in Galapagos. The only site that continuously goes from like yesterday right down into the Ice Age.
Stedman quickly got down to the job of sifting tiny bones out of buckets of sediment. Then, working in a shipboard laboratory, he took a first look at what he had found.
Here's the results from 1 bucket full of sediment from layer 2 in our excavation, Barn Owl Cave on Floriana. This is unsorted, a bunch of snails and bones, maybe several hundred of them.
The Barn Owl dig produced a bonanza of ancient remains, tortoises, snakes, lizards, birds. Stedman and other scientists will study these bones for several years, tracing genetic changes, extinctions, and evolution of wildlife communities over many centuries.
So I'll be able to say, okay, 3,000 years ago the fauna looked like this, 5,000 years ago it looked like this, and then importantly, even back in the Ice Age, maybe 10, 12, 14,000 years ago, these are the species of birds that lived on Floriana. So for the big picture evolutionary questions that people have about the islands out here, this is going to be a real nice piece of the puzzle.
From what depth? We took it all the way up.
We can put on the tip.
To about 450. First we got the one with polka dots and a blunt nose. We got a new gardeneel. Or at least we got a gardeneel of 500 feet, and what it's doing down there, I don't know.
Jesus, that's awful deep.
It's awful deep. Then we got, look at that fish. Look at that.
Life among the Discovery Expedition scientists included a large amount of good-humored rivalry.
You spent too much time in mid-water. Head for the bottom.
I wasn't even on the dive.
The deep-water scientists kidded the shallow-water scientists, and all three marine scientists teased the land scientist, Stedman, as Dr. Dirt. Meanwhile, he referred to them as fish people.
I really get a kick out of these fish people on the trip, the scientists going down in the submarine. In many ways, what they're doing reminds me of my first couple trips to Galapagos, which were essentially pure exploration. The nice thing is, just as you might predict the way science works, some of their preconceptions are right on the money. They think, well, I'll bet there's a fish of this genus. It's never been recorded in Galapagos. I don't see any reason why it shouldn't be here. Sure enough, they find it.
Stedman says that 20 to 30% of Galapagos terrestrial species are found nowhere else on Earth. And he says underwater studies, including the discovery expeditions, are indicating a similar 20 to 30% rate for marine species. Stedman's enthusiasm for underwater research led to an invitation to make a dive in the sub. The normal pre-dive briefing was focused a little more than usual on the fundamentals of undersea life.
We call them fish, and they have fins and scales and a terminal mouth and an eyeball next to the mouth. You should be able to recognize.
On deck, another round of preparation and outfitting.
This high-tech sampling device for you so that you will have the opportunity to really make some valid collections.
This is my junior ichthyologist starter kit.
That's right. Anyway,
so if I come back with a fish, will I be a real ichthyologist?
Look, equipped like this, you're already fooled 9 out of 10.
Oh, I love
it. Despite the joking, this was a serious dive. John McCosker was in the aft chamber, and they stayed under for 3 hours, settling briefly on the bottom, about 1,400 feet down.
The only weird feeling of the whole trip is going in the water, because then you're sort of bouncing around and you're seeing a little bit of air and a little bit of water, and you might see the ship for a while, so that's a little funny.
Okay, Don, here you go. Let me know when you get a seal.
The sphere did feel claustrophobic at first. I'd hate to be a tall person. I don't think it's made for basketball players. As someone who doesn't do well with electronics and lots of gadgetry, as I looked at the control panel there, it seemed like I was in the space shuttle, and I really admired Don, how he could handle that. Going down in the sub makes me realize what limitations someone like Darwin had when he was working 150 years ago. I mean, in Darwin's time, people weren't even able to explore the 100 or 200 feet below the sea, much less 1,000 or 2,000 or 3,000 feet. So this is just a world that was beyond the realm of comprehension. People in Darwin's time didn't even know how deep the oceans were. I mean, they knew it was deep, but what did deep mean? It's wonderful. The experience of going down in that sub, you have to right away, I think, recover from the fact that you're drowning in your own ignorance. At least that's the way I felt. It's a thrill. I love it. I learned a lot, but it's just not what I do. I mean, these marine biologists have such a different set of technologies, a different way of approaching things, and just a different perspective. Well, we got some rock samples.
Oh, good, yeah.
We scored on some fish. I think they were fish. Things with fins and good swim. Mouth in the front, tail in the rear end.
There's nothing like it, is there?
There's nothing like it. No, it was wonderful. It was great. Beats bird watching on a short-term basis. It was utterly thrilling, the whole thing. It wasn't anything like I thought it would be. I didn't know what I thought it would be, but
it was better than that.
It was a lot better than that, yeah. Yeah, so getting a fix on Galapagos has always been famous in evolutionary terms for its terrestrial life. Maybe we're sort of at a threshold now where Galapagos will be on the map among marine biologists just as much as it's on the map among terrestrial biologists. What I'm really hoping is that, 50 years from now, people will take a look at this expedition and sort of chuckle and say, man, can you imagine, how did those people live back then? What primitive conditions, they didn't know, they were doing the best they could, but they didn't quite have much of a grasp on things. That'd be great.
Scientists use the phrase introduced species to describe newcomers that upset the ecology of a pristine place. Ecologically, no species is more upsetting than human beings. After people arrive, even well-behaved, respectful people like most of the tourists who come here, things can never be the same. There are now daily jet flights to the Galapagos. The trip from South America takes only an hour and 20 minutes. The Galapagos are part of Ecuador. The Ecuadorian government regulates the flow of tourists who generally come here to admire the island's fragile beauty, not to disrupt it. The money they spend is very welcome in an underdeveloped country. To an extent, this flow of revenue works in favor of preserving the natural wonders of the islands because tourists would simply not come here if the islands were spoiled. Nevertheless, people leave their mark.
Even in a place seemingly as remote as Galapagos, I mean, there are more than 50,000 tourists a year coming out here. So the beach we're sitting on, boy, what a wonderful beach. It looks great. And within a 50-foot radius of us here, you could pick up 1,000 pieces of garbage. Now, garbage in itself maybe doesn't cause extinction, but nevertheless, it represents a type of human impact. Like now there are fire ants on Espanola Island. It's the only significant nesting colony of the waved albatross. What's it like to be a little chick of a waved albatross or a big fat chick of a waved albatross fighting fire ant bites all the time? What if a little red ant like a fire ant causes the loss of this entire species? Fire ants that came on shore with someone's food or on someone's clothes. We need to tread lightly on these sorts of places.
This is Academy Bay, one of 3 areas where the 15,000 residents of the Galapagos are allowed to live. To go elsewhere, even for scientific research, requires numerous permissions from government and conservation agencies. Galapagos is considered one of the world's most protected natural habitats. Ecuador wants to keep it that way, on land and in its waters, within 15 miles offshore. But enforcement is difficult. The Discovery expedition, exploring one day in rich protected waters, encountered a fishing boat clearly violating the 15-mile limit.
They're working, and there's another fishing boat farther out. Yeah, their nets are down there.
Juan Carlos Naranjo, the National Park Service guide assigned to the Discovery expedition, is reporting the illegal fishing to Ecuadorian authorities.
Habíamos quedado en stand-by sobre el reporte de las embarcaciones en las proximidades a Roca Redonda. The problem right now is that these people is fishing right into the park waters, They're only about 2.5 miles away from Roca Redonda. And we already have reported them to the port captain on Santa Cruz. They will probably come and get them. If they are able to capture them, what they will do is keep the boats, and they will have to pay to be able to get their boats back.
The ship flies no flag. Juan Carlos says most violators are Costa Rican, Venezuelan, or Ecuadorian. By radio, the boat's captain refuses to identify himself and rebuffs Juan Carlos with insults.
They get what they catch it.
Then, stalling for time while the boat pulls up its nets, he insists that he has special permission for tuna fishing. Then, he promises to stop immediately.
His name is Capitan Fernandez, and they are working on selective fishing of tuna, which is hard to believe.
You mean since we've been at sea, they've changed all the rules in Ecuador?
In 2 days, by the radio.
By radio. This is how decisions are made?
Is what he says. I mean, I don't believe this guy for sure.
Either. Ecuador is smarter than that to sell out the national park in 2 days and
in 2
allow
days,
him on the radio to go out and start fishing in the
Exactly.
national park. That would be like allowing a
yeah,
commercial elk hunting project to take off in the Yellowstone National Park by radio.
Exactly. No, by radio things don't work.
Ecuador is smarter than this.
What worries me is the big ships that we saw over there farther out.
So they're fishing in the national park, delivering it to the mothership.
He said we Ecuadorians are allowed to come in. We're not foreigners, but we're talking about motherships. We're talking about tons of fish going out of Galapagos.
You think this goes on every day?
From the national park.
Is this an everyday occurrence in
Unfortunately, yes. We need to work on the conscience of the people here. And unfortunately, there is no common sense on the importance of conservation.
The Discovery vessel departed before authorities arrived. Unofficial word said the fishing boat had been confiscated temporarily and fined. But its catch had shown up in Galapagos seafood markets. There was no reason to think illegal fishing was more than briefly discouraged. While tourism and illegal fishing are relatively new threats, the greatest damage to Galapagos over the years has been inflicted by animals or introduced species that people brought to the islands: dogs and cats, farm animals like cattle, goats, donkeys, horses, pigs, and also rats that stowed away aboard ships.
When they get on islands, they're just cut loose. There's virtually no check on their populations, so their numbers grow rapidly, and they have devastating effects on the vegetation. They also have a devastating effect on animal populations.
Stedman visited the Darwin research station, where baby animals are safely nurtured till they're ready to survive on their own.
These are 3-year-old tortoises from the island of Santiago. Santiago is an island that has a lot of problems with introduced species, and so even though there's a wild population of tortoises there that in fact can lay eggs in the wild, the eggs are eaten especially by rats and pigs. So wardens from the national park and from the Darwin station dig up these eggs as soon as they're laid, bring them to the Darwin station to be incubated here, and then they raise them here until they're 4 or 5 years old. This tortoise here is about 3 years old now, so it has a year or two to go before it can be let go back on Santiago. By 1 year old, these tortoises are sort of rat-proof. So a rat can't hurt a tortoise after it's about a year old. But on Santiago, with all the feral pigs they have thousands of feral pigs on Santiago. The tortoises, these poor little baby tortoises, need to be about 4 or 5 years old before they're pig-proof. So this is a good example of very active hands-on manipulation of a wild population in order to keep it going. Without the Darwin Station and the National Park working every day with these little tortoises, the tortoises wouldn't survive. So while maybe the funding comes more from countries outside of Ecuador, it's Ecuadorians working hands-on as well as conceptually designing these programs that really make these programs work.
The Galapagos evolved in isolation, and isolation was their only protection. Now, that isolation has ended. It's a paradox that everything that makes the islands attractive seems to put them in jeopardy. Their remote solitude draws visitors by the thousands. Their unspoiled beauty is a magnet for tourism and commerce. Their natural abundance creates a virtual feast for introduced animal predators and human exploiters. The question is whether these humble creatures and their vulnerable ecology can withstand the human response to their unique appeal, whether they can survive the most traumatic of evolutionary events, the arrival of people.
Galapagos is really famous for how tame the animals are. This tameness in Galapagos animals has evolved because the species that live out here have evolved in the absence of mammalian predators. So these animals have virtually no predator response. So this tameness is an island adaptation. It doesn't occur to these species that we're something that might kill it.
Nature is efficient. If fear isn't needed, it fades away. Animals become tame. But evolution lacks foresight. It failed to anticipate the coming of humans. Early sailors in the islands took cruel delight in the vulnerability and innocence of Galapagos animals. Killing them was so easy. Charles Darwin never used the phrase survival of the fittest, but evolutionary adaptations do tend to make species better at surviving, usually by creating specialties. The specialty gives them competitive advantage or allows them to move into a niche where less competition exists. For instance, instead of competing with other gulls in daytime feeding, the swallow-tailed gull became a specialist in feeding at night.
The swallow-tailed gull is unusual among gulls in that it has a very much enlarged eye, which is a beautiful adaptation for feeding nocturnally. The swallow-tailed gull feeds mainly on bioluminescent type organisms that light up the surface of the sea at night. The red eye ring is another adaptation for functioning nocturnally.
The most famous Galapagos adaptation story, a classroom cliché for many years, involves the finches. A single finch species arrived in the islands, but later generations developed beaks specialized to fill different feeding niches. For example, there were no woodpeckers in Galapagos, so one finch developed a woodpecker-like beak. Others became cactus eaters, tick eaters, vegetarians, bloodsuckers, tool users. 13 finch species, 13 different beaks. A parallel to the finch's beaks turned up one day when the Discovery expedition captured these two hawkfish. The short snout is better for picking food off the surface of rocks or coral. The long snout is an adaptation for reaching into crevices. Maybe the best-known Galapagos adapter is the marine iguana. According to common thinking, it arrived in Galapagos as a land iguana. Food for land creatures was scarce, but the Galapagos seashore offered abundant feeding. Over millions of years, some of the land iguanas ventured into the water. Individuals with better tails for swimming and shorter snouts for eating had a competitive advantage. They could become divers for algae. Over millions of years, the advantages that made them divers were accentuated until the marine iguana separated from the land iguana and became a new species. This process Darwin called natural selection, nature selecting modifications. An iguana originally designed for land, being redesigned for water.
Because the ocean is cold in Galapagos, the marine iguanas lose a lot of heat when they go out to graze on algae underwater. So the marine iguanas that you see lined up here are aligning themselves to maximize the solar radiation that they soak up so that they can warm up again. A lot of times you'll see marine iguanas shoot a salt spray out of their nostrils. It seems a little rude, but they do that regularly as a way to extrude salt.
Like the marine iguana, the flightless cormorant evolved from its original design and became a diver. Because it no longer flies, its wings are atrophied and useless. Its power has shifted from upper body to lower body. No other cormorant in the world is flightless, but no other cormorant has such large and strong legs and feet. Expedition scientists, while scuba diving, saw a flightless cormorant catching a fish at a depth of 60 feet. Cormorants have a courtship ritual that humans might find comical. The birds present each other with tokens of affection in the form of dried seaweed. The male frigate bird also has a unique approach to courtship, inflating its bright-colored throat sac and making a clacking sound to attract females. The blue-footed booby does a special mating dance called sky pointing, supplemented by honks and whistles. Special mating behavior and colorful displays might be a way of helping creatures recognize and mate with others of their own species, a definition of species being a population that reproduces only within itself, preserving its distinct identity.
This is Black Turtle Cove on the north coast of Santa Cruz Island. These sea turtles come into these protected waters to mate. The male green turtle is smaller than the female adult green turtle. It's advantageous for the female to be larger than the male because that way her buoyancy can support the male and keep them both above water. She could actually drown. This is Roca Redonda, one of the most dramatic seabird concentrations in the Galapagos. A hardcore birdwatcher would just go nuts here, would really love it. All right. Thousands and thousands of seabirds.
To share the view of the great Galapagos seabirds, the Discovery expedition brought along its own airplane, packed in crates for assembly on deck. Called an ultralight, this is a small, open, two-seat flying machine powered by a snowmobile engine. These views are off limits to tourists, and of course they were unattainable for Darwin. They seem to fulfill every fantasy of fascinating lost islands in the Pacific, craters still fuming, scenes untouched by time, no sign of human presence. The Galapagos seems a perennial source of new things, said Darwin. Today's scientists would second that. They would also tell you that new things, not just new creatures and vegetation, but new bacteria, viruses, all forms of life, are not only evolving, but evolving in many cases much faster than Darwin thought. And it's happening everywhere. The difference between evolution in these islands and elsewhere is only that nature's creativity stands out more vividly against the pristine landscape of the Galapagos.
Here it's been very, very rewarding. We've seen something new every dive, something new to us, something new to science. Yet we will have to spend a lot of time verifying and confirming that what we saw has not been overlooked or misidentified or misinterpreted in the past in the literature. And I'm sure that much of what we do over time will be challenged and questioned, and that's all part of the process of science.
6 months after it ended, John McCosker estimated that the expedition had discovered about 24 new species, meaning that a discovery took place on almost every day of the diving. Two scorpionfish found by the expedition are not only new species, but belong to no known genus. A new genus will be created to demonstrate their evolutionary uniqueness. Classification of new species is a long process that might take several years. Other important findings will be evaluated over even longer periods as the academic discipline of the lab follows up on the excitement and adventure of discovery.
We think that this is probably a new species, one that's not been described before, and I'm certain that this is the only footage available of cirrate octopuses in good condition like this.
We don't know what species this is. We're not familiar with it. It might be unique to the Galapagos. It'll take a lot of work in the museum examining other specimens and comparing it to be sure of its identity.
This is Colobodema, a beautiful little deep-sea medusa that has some very special tricks up its sleeve. Its color pattern in white light is one of blue tentacles with white tips and a bluish tint to the swimming bell. Also, when white light shines through the muscle tissue that comprise the bell, the fibrous structure of the muscle tissues breaks up light into shimmering patterns of iridescence.
This creature is a batfish. His pelvic fins are modified into fins which can walk, very large eyes to see his prey, and between his eyes is a little organ used to emit chemicals which attract small invertebrates to his mouth.
Pelagothuria is completely unique among the sea cucumbers in that it never spends any time on the sea floor. This is the first time that anybody has had the opportunity to see what it feeds on and to be able to characterize its role in the deep sea community here. This is an extraordinary deep sea fish. Common name is the tubai. This is probably the first living specimen anybody has ever had in a position to be able to photograph.
And while the fish people study their specimens in the future, Dr. Dert will be sorting and studying 15,000 bones brought back from Barn Owl Cave. David Stedman excavated bones representing at least 12 species, 9 of which are extinct on Floriana Island, and 2 of which were found for the first time. Meanwhile, further study of stratifications in Barn Owl Cave revealed prehistoric changes in climate with an impact on evolution.
Galapagos is such a great place to study evolution, and evolution is really the key to life. Evolution as time perspective to life. We can look at where we came from, where other organisms came from, and those same processes are going on. It gives us a peek at the future. In some cases, a really good look at the future. It's sort of ironic we're losing a lot of things right now when we're finally getting the tools necessary to study it in enough detail to understand it.
This submersible is diving in some of the richest, most exotic, most unexplored waters in the world. Scientists aboard the sub, using its unique ability to chase and capture live fish and other creatures in deep water, are bringing back extraordinary sea life, including specimens of fish never seen by human eyes.
I saw more new critters on this dive than I've ever seen on any other dive in my life.
On expedition in the waters of the Galapagos Islands, they are discovering, on average, a new species every day.
The video we've taken on this is great. Fish everywhere.
For a marine scientist, this is the ultimate.
Bizarre midwater squid.
Those are actually sea cucumbers, and we've seen shallow water sea cucumbers, and now you're seeing what a sea cucumber looks like in the deep sea. These are really strange.
This is a scientist's dream come true. To spend a month at the Galapagos, every day in the water, in the sub, working with these animals. It's a high that'll take a long time to come down from, but there's going to be a lot of work when we get home. It'll probably be 6 months or a year before we really even understand all of the information that we've gathered from this expedition. But no doubt about it, Galapagos is Mecca for a biologist, and here we are in the Holy Land.
On station in the world's foremost natural laboratory of evolution. A discovery expedition to the Galapagos, beyond Darwin.
We have a seal.
The Galapagos are dots of land on a vast Pacific. From the 1600s on, they were a lonely stopping place for pirate vessels and ships drifting off course. Now, instead of a place you get to by accident or bad luck, the Galapagos are a magnet for travelers, and especially scientists attracted by the chance for dramatic discoveries.
It's silly to think that the age of discovery is over. It'll never be over. It will keep going and going and going. We'll learn all kinds of new things. I can't wait to be old and gray and have some new person come out and start digging up fossils out here and tell me how wrong I was. Be no problem, be fun.
In 1835, these humble, unknown islands were visited by a humble, unknown scientist, Charles Darwin. He was the first scientist to set foot here. Now other scientists come in his footsteps, drawing on this almost magical source of knowledge about the evolution of life.
Actually, I'm so excited, I can't describe it. I gotta go warm up and be able to explain it to you.
160 years after Darwin's visit, the Discovery Expedition arrived to gather new knowledge from these islands, from Galapagos worlds Darwin never saw, underground and underwater. The Harbor Branch research vessel Seward Johnson reached Galapagos after a 10-day, 2,000-mile voyage from its home port in Florida. Aboard were 38 people, the ship's crew, the Discovery film crew, and a scientific contingent. Spending 1 month in the spectacular waters of the Galapagos, scientists made 55 deep dives by submersible and many more shallow water dives by scuba. The submarine dives yielded fantastic deep-water specimens, many of them staying alive for hours or days, long enough for close-up study and living documentation.
Every biologist cuts his teeth on Charles Darwin and the voyage of the Beagle and the Galapagos. It's such an extraordinary place because the process of evolution occurs right before your very eyes. You can see how these different islands allow for the finches or the tortoises to radiate and speciate and evolve. But few people appreciate that the same thing happens underwater.
Charles Darwin, when he arrived here, didn't know about evolution underwater, or for that matter, on land. In fact, when the Galapagos offered him a hint of nature's greatest secret, he didn't see it. The Charles Darwin who landed on this beach was 26 years old, a medical school dropout, a young man whose sole passion was observing nature. Following this passion, he signed on as ship's naturalist for a 5-year voyage aboard the British survey ship Beagle. After mapping the South American coast, the Beagle started home across the Pacific, making a fateful visit in the Galapagos, 600 miles west of South America.
I have a hard time comparing what I do with Darwin too much because, to be honest, I think it's pretty egotistical, even though it sounds good. And when you go to Galapagos, automatically there are comparisons with Darwin. That's almost unavoidable. But Darwin was cutting edge. His observational ability was unparalleled.
But it didn't take unparalleled ability to observe the wonders of the Galapagos. Darwin beheld a fantastic spectacle. He saw giant tortoises, thousands of them. Birds with shriveled wings that had given up flying, but thrived as shoreline divers. Penguins and fur seals and sea lions, creatures associated with cold climates, but the Galapagos are on the equator. He saw land iguanas, resembling those he had seen in South America, but he also saw sea iguanas that fed underwater, a creature never seen anywhere else. Darwin spent only 3 weeks ashore in the Galapagos, visiting 4 of the 16 islands. He took notes and filled his bag with specimens, then he left. He may have had inklings of evolution, but he didn't see the light. Understanding what he had seen and working out a theory explaining it took a quarter of a century. It's one of the great sagas in the history of science. Darwin's theory of evolution shook not only the scientific, but also the religious and social foundations of the Western world. The reverberations of Darwin's theory are still felt today, felt with a passion. It's the passion of fundamentalist religion, raging against Darwin, insisting on a biblical version of creation.
That one's deeply forked.
It's also the passion of scientists who believe that Darwin opened new worlds of knowledge, who build on his insights in an ongoing process of science, who regard such fundamental evolutionary principles as natural selection as an unshakable premise of their work.
But its closest relative is in Hawaii.
You know, the irony of all of this is that here we are on a very, very modern ship, and in fact, with the Discovery program, we've had email, and one of the first emails we got was someone asking the question, does your experience in Galapagos change your view about that controversial theory of natural selection? My response was, Madam, it is not controversial, and it's not a theory. It's a fact. I only wish that we could take everybody on this planet and send them to the Galapagos to see natural selection in action. It's so obvious here.
Aboard the Seward Johnson were 3 top authorities on sea life.
It was just crawling across the bottom at about 1650.
The expedition's chief scientist, Dr. John McCusker of the California Academy of Sciences, an expert on shallow water fishes.
Doing okay. It's a little warm up here on top, though. We got to get in an ice bath.
I believe it's a medusa, or jellyfish. But
Dr. Bruce Robeson, a deep-sea specialist from the Monterey Bay Aquarium Research Institute.
This is one I've never seen before, and it's remarkable.
You think this is the male of the new species of the lopus that we have?
And Dr. Grant Gilmore of the Harbor Branch Oceanographic Institution in Florida, an authority on Atlantic and Caribbean marine life, studying comparative evolution in the Galapagos.
Beautiful fish, very difficult to capture.
Well, as a strategy, I assembled a crew of scientists that could both examine the deep ocean, as well as the rocky reef, as well as the shallows. And then we threw in Stedman to give us a reality check. He's a birdman who's never been underwater.
The birdman was Dr. David Stedman of the University of Florida. Stedman is an expert on Galapagos wildlife in the present, but also in the past. As a paleontologist, he's done extensive work on the evolution of land life in Galapagos.
A big difference between what I'm doing and what the marine biologists are doing here is that, I'm going into the past to look at evolution. So I'm digging down, and by only digging down a meter, I might get back 10 or 15,000 years, but nevertheless, I'm going back in time to see what has happened evolutionarily. These guys are studying organisms that are still alive today. So the studies that they do are based purely on living fauna, and there isn't a fossil record out here that would allow them to go back in time.
Darwin, not having a face mask, was unable to get underwater and really appreciate that evolution's going on there too. So I often thought, what would Darwin have thought if he had been able to do what we're going to do on this expedition? Would he have realized that nearly everything underwater here has different factors affecting their survival, their evolution, which makes it more challenging and more interesting to an evolutionary biologist.
Also on board was a leading underwater filmmaker, Al Giddings. Giddings has shot underwater scenes in many documentaries and in feature movies including The Deep, The Abyss, and several James Bond films.
I've seen my fair share of the undersea world, but Galapagos, with the tools that we have here, And the scientists that are on the front line here is incredibly exciting because everything that we're doing is sort of a first. Nobody's really gone below probably 200 feet here, so anything below 200 feet is relatively new to science or totally new to science. So I'm always excited to be on the cutting edge of that kind of new frontier.
I believe this is the first time that any kind of research submersible has ever been available to study the deep living creatures that live here around the islands. Being able to be an explorer in the sense of a 19th century explorer, only one who uses 20th and 21st century technology to make those explorations is very exciting.
The urge to explore is timeless, but the technology changes dramatically. Charles Darwin's undersea technology was just a fishing line and a small tow net. His land tools weren't much better. On the Beagle, he was lucky to get a corner of a table as workspace. Except for mail at long intervals, he was totally isolated from the scientific community. Everything Darwin didn't have, today's scientists do have. For instance, this sub, the Johnson Sea Link. Don Libator,